Today, let's take a look at this LeetCode challenge problem, house robber. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security system connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given a list of non-negative integers representing the amount of money of each house, determine the maximum amount of money you can rob tonight without alerting the police. And the constraints we have is we have at the most 100 houses, and each house has at the most $400. So if we don't want to alert the police, the only constraint that we have is we shouldn't break into any two adjacent houses, right? So I think this is a classic dynamic programming question. So when we ask about find the maximum amount of something or minimum amount of something, this type of optimization problem, we need to think about using dynamic programming technique. So in terms of dynamic programming technique, it's an optimization technique which breaks the overall problem into similar but smaller sub-problems. Then we gonna solve those sub-problems. And when we solve the sub-problems, we will memorize the solution because we don't want to repeatedly solve those sub-problems. And eventually we're gonna use those solutions of the sub-problems to find our optimal solution for the overall problem. So that's kind of the idea of dynamic programming. So back to this problem, what's gonna be our sub-problem? So we are given an array, right? We are given an array. Each element represents a house. I think the index represents a house and the value represents the amount of money the house has, right? So the subproblem can be defined as what is the maximum amount of money we can rob from house 0 to house I. Let's use function dpi. dpi gonna represent the maximum amount of money we can rob from house 0 to house I, right? So when we add house I, we have two options, right? The first option is we just rob this house. If that's the case, the amount of money we can rob so far is numbers I plus dp I minus 2, because we are not allowed to rob the house I minus 1. We just rob the current house and then plus the amount of money we can rob from house 0 to house I minus 2, right? The second option we have is we skip the current house because we already robbed the house I minus 1. If that's the case, dpi will be the same as dp I minus 1, right? So this will be our transition function. So we're gonna pick up the maximum value between these two when we calculate dpi. Yeah, let's code it. Let's first check the input. If numbers is null or is empty, we return 0. Right, then we need a DP array. Represents the maximum amount of money we can rob from house 0 to the current house I. So what's going to be our base case? DP0 will be numbers 0. If we only have one house, we just grab it. Right? And if we have two houses, what we gonna do? We're gonna rob either one, right? Which one has more money? We just rob it. Yeah. Okay, so since here our base gonna use two indexes, let's add another check here. If numbers dot length equals 1, we just return numbers 0, right? Otherwise we just do the regular logic. Okay, let's go to check these houses one by one. We start from the third house, which has index 2. So at house I, we have two options. And the maximum number of money we can rob at this point will be max.max. We have two options. One is DP I minus 1, right? We don't rob the current house I. Another one is we rob the current house, then we need to add DP I minus 2. Right, eventually we just need to return DP, the last element of DP. Okay, let's compile it. Okay, submit it. Accepted, and the time complexity and space complexity are both O(n), right? Because we need to iterate the array. But can we do some improvement on the space complexity? Do we really need to have this DP array? Because all that we need is we need to know when we at house I, we need to know the maximum amount of money we can rob at I minus 1 and I minus 2, right? So these can be we can use two variables to keep track of these two values. Let's give a try. So let's say okay, so this represents the house I minus 2, and this represents the house I minus 1. And we need to define a temporary variable. Let's call it current max. So the current max, also we have two options. One is this max prev, right? Another one is max prev plus the current number. But every time after we find the maximum amount of money we can rob at current position, we need to update these two. So max prev will be maximum prev, and the maximum prev will be our current maximum, right? Eventually we just return this maximum prev. Yep. So this can help us achieve a O1 space complexity. Time complexity will be the same as before, which is ON. Let's submit it. Yep, accepted.